Children, now we see time and work. Time and work. In this time and work, we are going to see unitary method. If two persons, you consider x and y, can complete some work individually in A and B days. That means x person complete the work in A days and y person complete the work in B days. We consider like that. Then their 1 day's work will be 1 by A and 1 by B respectively. Okay, I understand, children? So if you consider two persons, x and y, x person can complete the work in individually A days, okay, and y person complete the work in B days. Then their 1 day's work will be, we consider 1 by A and 1 by B respectively. Okay. Then they working together. A person and B person working together. They are 1 day work. They are one day's work is 1 by A plus 1 by B. 1 by A plus 1 by B. Because the 1 day's work, x person's work is 1 by A and y person's work is 1 by B. Okay, they are working together means 1 by A plus 1 by B. Okay, so this is equal to, you do the cross multiply, what comes here? B plus A by AB. Okay, we consider this as A plus B by AB. A plus B by AB. Okay, so their 1 day's work, working together, their 1 day's work is A plus B by AB. Okay, okay. If x and y together, the person x and y together can complete the work. In, see how many days this one A plus B by AB you write in the reciprocal. That is AB by A plus B days. Okay, understand, children? See, 1 day's work we consider 1 by A and 1 by B. Working together in 1 day's work is 1 by A plus 1 by B, that is A plus B by AB. Okay, so working together, they are complete the work A plus B by AB. Okay, so if x and y together can complete how many days? That is, you write in the reciprocal A by B by AB by A plus B days. Understand, children? Okay, this one you have to apply in that exercise 4.1. The first topic, fill in the blanks in the first sum. Okay, so A can finish a job in 3 days, whereas B finish it in 6 days. Then time taken to complete the job working together is dash days. Here we apply this unitary method. Here A complete the work in 3 days. Am I correct, children? 3 days. And B complete the work in 6 days. 6 days. Okay, so in both A's 1 day work is 1 day work. How much? That is 1 by 3. 1 by 3. And B's 1 day's work. B's 1 day's work is 1 by 6. Okay, then they are working together. Their 1 day's work is together. Working together 1 day's work. 1 day's work is, what do you write? See, 1 by 3 plus 1 by 6. Okay, do the cross multiplication. What comes here? See here, the LCM is 6, isn't it? So your numerator and denominator multiply by 2. So 2 plus 1 is 3. 3 by 6. Okay, so 3 by 6 means that is 1 by 2. 1 by 2. That means they are working together. 1 day's work is 1 by 2. 1 by 2. Okay, now we are going to find out they are working together. That means A and B together complete the work in how many days? We have to write in the reciprocal. I said no, here we say, see no, A plus B by AB means here now the X and Y person complete the work together means that is in the reciprocal. So AB by A plus B. Like that here also, here come 1 by 2. What is the reciprocal that? 2 by 1. So you consider that is 2 days. 2 days. Understand children? So what comes here in the fill up? 2 days. Understand? A can finish the work in 3 days and B finish the work in 6 days. They are working A's 1 day work is we consider 1 by 3. Okay, B's 1 day work is 1 by 6. Okay, so they are working together. 1 day's work is 1 by 3 plus 1 by 6. Okay, so that gives 1 by 2. 1 by 2. Then we find out the A and B together to complete the work in how many days? How do you find out? We have to write in this reciprocal. So that is reciprocal is 2 by 1. That is 2 days. We discuss about compound variation. What is mean by compound variation? Before that, just we recall what is mean by direct variation and inverse variation. Okay. So direct variation. What is mean by direct variation? If one quantity is increased, then the other also increase. If one quantity is decreased, then the other also decrease. That is called a direct variation. That means, for example, time and distance. The time and distance. Okay, if a distance increase means the time taken to cover the distance also increase. Okay, so the example for direct variation is time and distance. Okay, distance. Okay, then purchasing quantity. Okay, so if items increase means the spending money also increase. Okay, so items, money. Okay, so spending money. So if items increase means the spending money also increase. So this type of variation is called a direct variation. Okay, then what is inverse variation? Inverse variation. If we take out two quantities, if one is increase, the other is decrease. Okay, then if one is decrease, then the other one is increase. That type of variation is called inverse variation. Okay, so for example, speed and time. Okay, so if you increase the speed means definitely the time taken cover the distance is decrease. Am I correct, children? If you increase the speed, time will be reduced. Okay, so time, speed and time. The best example for speed and time. Okay, speed, time. Okay. The next is if a number of workers is increased means definitely the time taken to complete the work that also decrease. Okay, so workers, number of workers, so time. See, if you increase the workers, definitely the time will be reduced. Okay, so this type of variation is called inverse variation. Understood, children? Okay, now we are going to see what is mean by compound variation. Okay, so compound variation means two or more variations combined with the sum is called compound variations. Okay, so that means direct to direct. So what are the possibilities in compound variation means direct to direct. Okay, then inverse, inverse, inverse. Okay, then one more, direct, inverse, then inverse, direct. These are the possibilities. These are the possibilities in the compound variation. So now we see exercise 4.4. First topic, fill in the blanks. Second one, if a 5% can do 5 jobs in 5 days, then 50 persons can do 50 jobs in dash days. That means how many days? Here we apply compound variation. Okay. Multiplicative factor method. We are going to apply multiplicative factor method. Okay. Okay. See how we write here. So first we have here persons. First we consider a person. Next jobs. Number of jobs. Then next one days. Number of days. Okay. So 3 days. So first one, how many persons? 5 persons. How many jobs? 5 jobs. In complete how many days? 5 days. Okay, write like this. Okay, okay. Then 50 persons, 50 jobs. 50 persons can do 50 jobs in how many days? That question you consider x. Okay, how many days? So number of days unknown, that is you consider x. Okay. Now persons compare with the days. Okay. So if a person increase means definitely the number of days will, working days will decrease. Okay. So if a 1 increase and 1 decrease means that is the inverse variation. So these two are in inverse variation. Inverse variation. Now compare jobs with the days. Jobs with the days. Here jobs also increase. Jobs increase means definitely the days also increase. Okay. Number of jobs increase means definitely the number of days also increased. Okay. So here this is direct variation. Direct variation. Okay. Okay. So this two variations combined together. So this is called a compound variations. Okay. So here we are going to do multiplicative factor method. This is called a multiplicative factor method. Okay. So here first which is unknown? X is unknown. Okay. Listen carefully. Here x is unknown. This is equal to, now x in before one is a 5. So first one you write 5. Okay. Then multiple. Here see. If this is in the inverse variation, okay, persons is in the inverse variation, person to days is inverse variation. So inverse variation means the first one you write in the numerator and the second one you have to write in the denominator. Okay, so first one in numerator, second one in denominator. Okay, then multiple. If a direct variation means here see this jobs and days in direct variation. So this one you have to write in the reciprocal. That means second one write in the numerator and first one write in the denominator. Okay, understand children? Listen carefully. This is called the multiplicative factor method. Here the unknown is days. Okay, so here you write x is here equal to 5 here multiple of. The next you have to write persons to days. Here persons is here, first one is 5 and second one is 50. Okay, inverse variation means first one in numerator, second one in denominator you have to write. If a direct variation means first one in denominator, second one in numerator, that means here see reciprocal. Okay, okay, good. And now you have to simplify this. 5 cancel, then 50 cancel. Okay. So how many days we need? 5 days. 5 days. Okay. So the unknown is 5 days. Okay. So what is here? 50% can do 50 jobs in 5 days. How many days? 5 days. Okay. Good. Now see the third one. A can do a work in 24 days. Okay. So A can do a work in 24 days. And A and B. A and B together can do the work in 6 days. How many days? 6 days. Okay. So here A only can do in 1 day means that is 1 by 24. 1 by 24. Then A and B together can do the work in 1 day means this 1 by 6. Okay. Here there is then B alone can finish the work in dash days. How many days? You have to find out the B alone can do the work in how many days. Okay. So you know that we need a B alone. B alone finish the work in how many days? How do you find out? This A and B both together can do the work in 1 day is 1 by 6. Okay. Then minus A alone can do 1 day in that is 1 by 24. Okay. So together minus A's. We get B's. Okay. Okay. So now what is the LCM of 6 and 24? See 6 4s are 24, no? So here 24 is the LCM. So here 6 multiplied with 4, we get 24. Okay. So here 4. 4 minus 1 is 3. 3 by 24. 3 by 24. You cancel with the third table here one time. 8 3s are 24. Here 8. So here comes 1 by 8. Okay. So here 1 by 8 you have to write in how many days B alone can finish the work in how many days. This is a 1 day's work. Work in 1 day. This is the 1 day work. Okay. So B alone can finish the work in how many days? See, you write in the reciprocal, that is 8 days. Understand, children? This is, we found only 1 day. B alone can finish the work in 1 day. That is 1 by 8 part of the work. B alone can finish the work in totally how many days can finish the work? 8 days. 8 days. Okay. So here in this fill up you have to write in 8. Understand, children? So now we see exercise 4.4. First topic, fourth one. A alone can do a piece of work in 35 days. Okay. If a B is 40% more efficient than A, then B will finish the work in dash days. How many days? That is the question. Okay. Here, A alone 35 days completed. Okay. So 1 day's work means 1 by A is equal to 1 by 35. Okay. Now we find out the 1 by B. 1 by B. So 1 by B means we write here 40% more efficient than A. So 1 by B is 1 by A of 1 plus how many percentage? 40%. Okay. So 40% means that is 40 by 100. Okay. So more efficient. Okay. So this is equal to here 1 by A is how much here? 1 by 35. Okay. So now here do the cross multiply. Here 100 plus 40 is 140 by 100. Okay. Then 0 cancel. Now here cancel with the 7th table. Here 2 times. Here 5 times. 7th table. Okay. Here 2 cancel with your 10. 5 times. So 1 by B is equal to 1 by 5 5s are 25. 1 by B is, that means 1 day's work is 1 by 25. So B will finish the work in how many days? You write in the reciprocal. B's work is 25 days. Okay. B alone can do the work in 25 days. So in this fill up you have to write 25 days. Understand, children? Good. Now we see here A alone can do a work in 10 days. So A's work is 10 days. Okay. That means 1 day's work is 1 by A is equal to 1 by 10. Okay. Now B's work is 15 days. 15 days. That means 1 day's work is 1 by B is equal to 1 by 15. 1 by 15. Okay. Now we have to find, they undertook the work for 2 lakhs rupees, 2 lakhs. The amount that A will get is, that amount that A will get is, okay, we have to compare the ratio. So we write 1 by A is to 1 by B. 1 by B, that is 1 by 10 is to 1 by 15. Okay. So now see here, you equate the denominator. Okay. So equate the denominator means here 10 3s are 30. So numerator also multiply by 3. Then here 15 2s are 30. So the numerator also multiply by 2. Okay. So what comes here? 3 by 30 is to 2 by 30. This 30 cancel. So what is the ratio here? 3 is to 2. 3 is to 2. A's ratio is 3 and B's is 2. So what is the total ratio? The total is 3 plus 2 is 5. Total ratio is 5. Okay. Now we find out only the amount that A will get. Okay. So A's share that is equal to, see, A's is 3 by, out of total ratio is 5. 3 by 5 multiple, total amount is 2 lakhs. 2 lakhs. Okay. Now find out here. So cancel with the fifth table. What we get here? 4 5s are 20. Remaining 4 zeros we have to write here. Okay. So 40,000. 40 multiple 3, that is 1,20,000. Okay. 40,000 multiplied by 3 is 1,20,000. So A's share is rupees 1,20,000. Understand, children? So in this fill up, the amount that A will get is 1,20,000 rupees. Okay? Good. Children, now see exercise 4.4, second sum. 210 men working 12 hours a day can finish a job in 18 days. 18 days. How many men are required to finish the job in 20 days? Working 14 hours a day. Working 14 hours a day. See, here this is a compound variation sum. Compound variation sum. We are going to do this multiplicative factor method. Okay. See. So here what are the quantities? See, number of men. Number of men and time given here in hours, then days, number of days. Okay, so I mentioned these 3 days. So here how many number of men? 210. How many hours? 12 hours. Can finish the job in how many days? 18 days. 18 days. The next one, how many men are required? So the question is how many men. So here you consider the unknown is X. Okay. Then time is 14 hours. 14 hours. Then the number of days is 20 days. Okay. Now compare with the unknown. See, now compare number of men and time. These two. Okay. So if here the time is increased. The time is increased. Definitely the number of persons will decrease. Okay. Okay. So this is the inverse variation. Okay. For one increase and one is decrease. So this is the inverse variation. So here you write inverse variation. Okay. Now compare with the number of men and the number of days. The number of men compare with the days. Okay. So if here days are increased. Days are increased. Okay. So definitely the number of men will decrease. Okay. So this is also the inverse variation. Okay, so this is the inverse variation. Okay, now how do you write x is equal to, unknown is equal to, what is in that first one, 210. Multiply, both are inverse variation, no? First one in the numerator and second is in the denominator. Multiple, here also. The first one in numerator, the second one is in the denominator. Okay, so now see. So 210. You cancel with the here 1 0 1 0 1 0 1 0 cancel. Okay. Then cancel with the seventh table here 3 times, here 2 times. Okay. Then 2 cancel with here 6 times. 2 cancel with here 9 times. So 9 3s are 27. 27 6 are 6 7s are 42 4. 12 plus 4 is 16. So 162 men. Okay, ma? So here needed number of men is 162. Okay. Okay. So here what is the question? How many men are required to finish the job in 20 days? Working 14 hours a day means the number of men is 162. Okay. Good. Now we see the third topic. Third one. A cement factory makes 7,000 cement bags in 12 days with the help of 36 machines. Okay? 36 machines. How many bags can be made in 18 days using 24 machines? 24 machines. Okay? Here what are the 3 quantities here? So see first cement bags. Cement bags. This also the compound variation sum. Okay. So the first heading is cement bags. The next one is days. Days. Third one machines. Machines. Okay, number of machines. Okay. Here are how many number of bags? 7,000 bags. So how many days they are needed? 12 days. So how many machines? 36 machines. Here how many bags can be made? So cement bags is the question. Okay, ba? So here you consider x, unknown is x. Then 18 days, 24 machines. 24 machines. Write like this. Okay. Then see here compare cement bags with the days. Cement bags with the days. Here the days are increased. So days increased means the producing cement bags also increasing. Okay. So both are increasing. Okay. So this is a direct variation. Okay. So this is direct variation. Okay. Now compare cement bags with the machines. Okay. Here machines are decreased. Machines are decreased. So the producing cement bags also decrease. Okay. So this also the direct variation. Both are decreasing. So that is the direct variation. Okay. Okay. Now what do you write here? X is equal to, in the top is 7,000 multiple. Here is the direct variations, you know, you write in the reciprocal. The numerator one, see the first one comes in the denominator, second one comes in the numerator, reciprocal. So 18 by 12 multiple, here also reciprocal, right? 24 by 36. 24 by 36, okay? Okay. Now, see cancel here, 18 2s are 36. 18 2s are 36. 12 2s are 24. Okay. So here 2 times. This 2 cancel. So here x is equal to 7,000 bags. The same. Okay. So 7,000 bags. Understand, children? So the answer is 7,000 bags. Cement bags. Okay. Understand, children? Good. Now we see. X is 4.4, fourth sum. A soap factory produces 9,600 soaps in 6 days. working in 15 hours a day. In how many days will it produce 14,400 soaps working 3 more hours a day? 3 more hours a day. Okay. So here what are the headings? Soaps. Number of soaps. Number of soaps. And days. Number of days. And time. Time mentioned here in hours. Okay. Okay. Now the soaps are first 9,600 soaps, 6 days and 15 hours. Okay. So, in how many days will it produce? How many days? So the question mark is in days. Okay. So the unknown is x. You consider unknown is x. Then 14,400. Okay, here in each day, the first one is 15 hours. Here what is given? 3 more hours a day. 3 more, that means 3 extra hours. So here already 15. So 15 plus 3 is here 18. So 15 plus 3, 3 more hours. So 15 plus 3 is 18 hours. Okay, okay. Now we take here x is equal to, here the 6 right here. Multiple. Okay. First you compare the days. So number of soaps compare with the days. Okay. So here the soaps are increasing. Soaps are increasing. Definitely the number of days also increase. Okay. So these two are direct variation. Direct variation. Okay. Now compare the days with the time. Okay. So here the time is increased. So the working hours increase means definitely the days will be reduced. Okay. So these two are inverse variation. Inverse variation. Okay. Now see this is a direct variation. No. So here you write in the reciprocal. Reciprocal means the second one in numerator. So 14,400 by 9,600 multiple. Inverse variation. Here the first one is numerator, the second one is in the denominator. So 15 by 18. That means as it is. Okay. So here only in reciprocal. Okay. Okay. And now cancel here 2 zeros cancel. Then the 12th table here. How many 12s are 144? 12 12s are 144. Then 8 12s are 96. 8 times. Okay. Okay. Now cancel with your fourth table, here 2 times, here 3 times. Okay? Okay. Now here cancel with the third table 5 times, here 6 times. Okay? Then the 6 cancel. Then 3 5s are 15. So x is equal to 15 by here 2. Okay, 15 by 2 means x is equal to 7.5. 7.5. What is the unknown here? Days are unknown. So 7.5 days. That means 7.5 days. 7.5 days. The unknown is 7.5 days. That is the answer. Understand, children? Good. Now we see here the fifth one. If a 6 container lorries can transport 135 tons of goods in 5 days, how many more lorries are required to transport 180 tons of goods in 4 days? Okay. So see here, what are that headings? 6 container lorries. So here you write number of lorries. Number of lorries. Then ton, weight that is given in the tons. Okay, tons. The next days. Okay. So 6 container lorries, 135 tons of weight goods transported in 5 days. Okay, 5 days. How many more lorries required? How many more lorries required? So here already 6 are. How many more lorries required means 6 plus x. We're going to find out the x value. Okay. Okay. To transport 180 tons. 180 tons and 4 days. 4 days. Understand, children? So here the question is, how many more lorries are required to transport? Already 6 lorries are using. So how many more lorries needed? So that one we are don't know, unknown. That only we have to find out. So you consider that is a x. Okay? Okay. Now the lorries compared with the weight. If lorries are increased, see, the tons are increased means weight or increased means definitely the lorries also increased. Okay. So this is direct variation. Next, compare the number of lorries with the days. If days decrease means days are decreasing. So number of lorries increased. Okay. So this is the inverse variation. Inverse variation. Okay. Now we see here 6 plus x. What is that here? 6 plus x. That is equal to 6 multiple. The first one is direct variation. No, right in the reciprocal 180 by 135 multiple. Here inverse variation. So 5 by 4. 5 by 4. Now cancel here. Cancel with the fifth table. Am I correct? Yes, fifth table. See, here 2 5s are 10, remaining 3, 35. So 7 5s are 35. Okay. So here cancel with the fifth table. 3 5s are 15, remaining 30. So here the 6 5s are 30. Okay. Okay. Now cancel with the ninth table. 9 4s are 36. Here 9 3s are 27. Okay. Okay. This 4 cancel. Here cancel with the third table. So 2 times. So 2 5s are 10. 6 plus x is equal to 10. Then x is equal to 10. This plus 6 moves to the right side. That becomes negative. So minus 6. So x is equal to 10 minus 6 is 4. So how many more lorries are needed? So 4 more lorries needed. Okay. So how many more lorries are required to transport? So 4 more lorries are required to transport. What's the children? Good.